Just about a mile away from Exploration Park here in the Katy area, Texas Hog Trappers says they've already caught over 120 hogs residents say have been troubling them for years.
Across Texas farmland, wild hogs have become a relentless threat, destroying crops and costing farmers millions. But these animals are so intelligent that fences, traps, and noise often teach them how to break in more effectively. This is more than a pest problem. It's a battle against one of America's most adaptable mammals. After years of failed defenses, some farmers discovered a smarter solution. By studying how wild hogs see, smell, and move, they found hidden weaknesses that allowed them to protect their fields without firing a single shot. What they learned completely changed the fight. The wild boar crisis. Wild hogs have become one of America's most destructive invasive species, with Texas at the center of the crisis. These animals tear through fences, trample crops, and uproot soil, causing millions of dollars in damage each year. Some farmers wake up to find entire fields destroyed overnight, leaving them with losses severe enough to threaten their livelihoods. The problem continues to grow. Around 6 million feral hogs now live across more than 35 states, compared with only 17 states in 1990. Their populations expand quickly because a single female can produce multiple litters each year, usually with 5 or 6 piglets. As their numbers rise, more farms are placed under constant pressure. Traditional deterrents often fail almost immediately. Electric fences, traps, loud noises, and other aggressive methods may work briefly, but the hogs quickly adapt. Instead of staying away, they study weaknesses, remember escape routes, and learn how to avoid danger. One Texas farmer described setting off a flare near a group of almost 60 hogs feeding at midnight. The animals froze for only a moment before calmly returning to the crops. They were no longer frightened by the threat. This ability to adapt makes feral hogs unlike ordinary pests. They are intelligent, persistent, and difficult to intimidate. To understand why they keep defeating every defense, farmers first had to examine the unique biology and behavior that make them such resilient opponents. It starts with their evolutionary history. Not really the wild pigs from centuries ago, but more like the byproduct of things crossing over. Uncontrolled hybridization between escaped European domestic pigs, Eurasian wild boar brought in for hunting, and all those long years of adapting to the wild American landscapes. Out of that mix, you end up with an animal that feels, socially speaking, a lot like domestic pigs, but with the survival instinct of wild boar. Then add their uncanny capability to learn from every failed attempt to stop them. And suddenly, you're dealing with a kind of opponent that is hard to discourage in the first place. Their smarts go past simple problem solving. These hogs pick up human patterns quicker than most animals out there. Fences, which used to be plain barriers, start looking like maps with marked weaknesses because the hogs watch, they memorize, and they keep doing it. Loud noises, too, once scary, don't really work after they've been repeated without consequences that matter. And at a certain point, even people lose the edge, especially when they get tired or just don't adjust fast enough. So the hogs keep operating with an advantage that leaves many farmers stuck, which is why the whole situation feels more tangled than just traps and fences. The economic threat is not something you can downplay. The United States is losing about $1.5 billion each year from damage, plus the control work linked to feral hogs. That financial hit keeps swelling as they push into new territory. Farmers like Marcus Webb are often cited. The guy spent more than $120,000 on defenses, installing, upgrading, and trying again across several years. Still, the deeper reasons these strategies fizzle out have only recently been looked at in detail and then backed by science. Figuring out why these animals aren't just scared off is the key. But it doesn't begin on the surface. It begins deep inside their brains. The secret lies in their biology and behavior, a truth that farmers and scientists alike had to come to terms with after years of trial, error, and loss. This unique biology is the key that unlocks why wild hogs have beaten every strategy so far, and eventually how farmers started to turn the tide. The boar's unique biology. Feral hogs don't respond to fear the way most mammals do, and this surprising fact changes everything about how we try to manage them. Researchers at Louisiana State University discovered that, biologically, these hogs may not be capable of experiencing fear in the typical way. It's not that they are simply braver or more stubborn. There is a fundamental difference in how their brains process threat and reward. Under normal circumstances, animals detect danger and respond with fear signals that trigger avoidance behaviors. But in feral hogs, when a highly desirable food source is close, the part of the brain driving reward completely overrides the region responsible for fear. This means hunger can suppress the natural fear reactions so strongly that the hogs continue feeding even while faced with threats. This rewiring explains why flashing lights or loud noises only cause a brief pause before the hogs continue their destruction. Misunderstanding this neurobiology has led many farmers down expensive dead ends. Marcus Webb invested heavily in electric fences, motion sensors, and noise devices, only to see the hogs ignore them and come back year after year. These deterrents were not weak or improperly installed. The hogs simply didn't perceive them as real threats. Instead, every encounter was just another data point added to their memory bank, teaching them how to circumvent or ignore the defenses. A study out of Mississippi kinda confirmed it by setting up multiple deterrents on the same herd for something like 30 days, and in the end, none of them really held their power. Every time one plan failed, the hogs seemed to learn the pattern more and more, almost like the attempt itself trained them better. So any long-term win basically got undermined. That constant adaptation shows how quickly they pick things up out there, faster than whatever technology we throw at them, or even brute force, can realistically keep pace with. This kind of insight pushes a change in approach. If we can't lean on that old, reliable trigger of fear to keep hogs away, then what do we actually aim for? The answer leans into other senses and habits that have been ignored for decades. Rather than meeting the hogs face to face or trying to scare them off over and over, the focus becomes reading the subtle ways their brain and sensory input guide their decisions. They can also rank hunger above fear in a pretty consistent way, and that connects to those precise internal biological clocks. Those clocks influence when the hogs get bolder, and also when they become less responsive to deterrence, meaning the timing can be used like a tool, carefully matching when they're most vulnerable. But more on that later. The main takeaway is that feral hogs aren't just difficult opponents. They're neurologically wired to shrug off fear more than other similarly sized mammals. So the typical deterrents just don't stick. One such vulnerability, even more fundamental than their brain chemistry, lies right in front of their faces in their vision. Invisible barriers, outsmarting their vision. Surprisingly, one of the wild hog's greatest weaknesses isn't strength or speed. It's how poorly they see in the dark. A 2022 study at the University of Georgia revealed that feral hogs' night vision becomes unreliable at distances beyond approximately 15 meters. This limitation is a critical blind spot farmers can exploit if they understand how hogs visually interpret their surroundings. Hogs do not see fences as continuous solid barriers. Instead, They perceive them as a pattern of contrasting points, reflective surfaces, gaps between bars, and sudden changes in light and dark patches on the ground. This fragmented view gives them a mental map filled with potential weak points, where they might break through at a standard metal fence with shiny horizontal bars and evenly spaced gaps. Unintentionally creates the perfect guide for these animals to navigate their way inside. Marcus Webb's costly electric fence turned out to be a perfect roadmap for the hogs, effectively inviting them in. When a consultant informed him that the fence might be the problem, Marcus was skeptical. But the solution was brilliant in its simplicity. He painted the entire fence in a dark, non-reflective color and installed opaque barriers along the base, eliminating every contrast point the hogs relied on at night. This modification cost less than $200, but made a dramatic difference. Within 3 weeks, intrusions dropped from an average of 4 times per week to 0. The fence didn't become stronger or more intimidating. It simply became invisible from the feral hog's perspective. Without a clear visual cue confirming a way in, their decision-making stalled, and they chose to stay away. This change challenges the intuition that stronger barriers must be more imposing. Instead, by understanding how these animals see the world, the problem can be solved through subtle camouflage rather than brute force. The invisibility of the barrier blocks the cue hogs need to act, halting them without confrontation. This discovery also raises a critical question. If their vision is so limited in the dark, what guides wild hogs as they find their way to a farmer's fields through dense woods at night? It turns out their biggest advantage is not sight, but smell. A sense so developed, it acts like a GPS in the dark, hinting at solutions that go beyond visual traps. And that begins to explain how some farmers have managed to not only defend their fields, but also lead these animals exactly where they want them to go. Leading with smell, the scent corridor. If wild hogs struggle to see clearly at night, how do they travel through forests and darkness to locate food? The answer is their extraordinary sense of smell. Scientists at CSYRO found that feral hogs do more than detect scents. They create detailed maps that help them understand where a smell came from and how recently it was left. Fresh scents attract them more strongly than older ones, allowing them to follow the newest and most promising food trails. A scent left 10 minutes ago can guide them differently from one that has been sitting for hours. Since hogs can detect food buried nearly a meter underground, smell becomes their most powerful navigation system. Marcus Webb realized that hiding the scent of his sugarcane was impossible. Deodorizers, irrigation changes, and coverings did little to stop the hogs from finding his fields. So instead of fighting their sense of smell, he decided to use it against them. Marcus created a directional scent corridor using several bait points. Each point became more attractive than the last, gradually leading the hogs away from the sugarcane and toward a final trap. Rather than relying on one bait station, the corridor guided the herd step by step, turning their strongest sense into a tool for controlling where they moved. So this corridor, it kind of made a really strong pull as it cut across the herd's normal ways of moving. Then it quietly nudged the hogs straight toward a big corral trap at the far end. What happened after that was honestly pretty wild. For 18 nights straight, his sugarcane patches had 0 intrusions. The hogs didn't really disappear from the place. They just decided to trail the more tempting odor pathway and basically skirt around the crops. In a way, this turned the hogs' own senses into a kind of steering thing, not some obstacle they needed to push through or outsmart. Then later came the next step, the next little innovation, when automated scent release setups were rolled out. These devices tuned bait strength depending on the weather, released scent in fixed rhythms, and they did all of it with no one standing around nearby. With no humans around, there were no extra scent trails, no disturbances that would tip the hogs off. Marcus didn't have to camp out in the field every night anymore, and that made the whole plan way more sustainable and stealthy, like it could keep going without constant attention. This breakthrough basically showed that if you shape the hog's surroundings through smell, you can get control that stays steady over time. Instead of going at the animals head-on or leaning on plain fear, the farmers started using biology like a tool against itself. They leaned on a strength the hogs had developed to survive, but that they hadn't fully learned to neutralize or resist. Still, even a scent corridor that's close to perfect, it wouldn't hold up by itself without one more key bit: timing. Because while hogs chase scent, they also follow inside patterns, the kind that decide when they're active and when they're cautious. Figuring out when to make the move, right when it matters, would be the line between getting them trapped and having the whole attempt fall apart. Understanding this internal clock meant learning not just where the hogs move, but when they do it most recklessly, and that knowledge unlocks a new level of control. Timing the strike. Feral hogs don't operate on instinct alone. They follow precise biological clocks that control when they feed, move, and take risks. Research from Auburn University found that even under constant hunting pressure, these animals rarely change their internal schedules. Their active and cautious periods remain largely fixed, giving farmers an important advantage. During peak activity hours, hogs become hungrier, bolder, and far less cautious. Their willingness to take risks rises sharply, making them difficult to scare away. Outside those windows, however, the same animals become hesitant and suspicious of traps, strange smells, or unfamiliar objects. Their behavior can change dramatically depending on the time of night. Marcus Webb used this discovery to completely change his trapping strategy. Instead of keeping traps active from sunset to sunrise, he studied weeks of camera footage to identify the herd's most active period. He then programmed the system to release scents and activate signals only during those exact hours. At all other times, the traps remained silent and inactive, producing no noise, mechanical movement, or unnecessary scent. The results were remarkable. Marcus increased his trapping success by more than 340% compared with operating the system all night. But the benefit went beyond removing more hogs. The animals appeared to remember not only where danger occurred, but also when it happened. After a successful trapping event, the herd often avoided that location during the same time window for several days. This time-based memory gave Marcus nearly 2 weeks without intrusions, damaged crops, or constant trap resets. Careful timing also prevented the hogs from becoming familiar with traps during cautious periods. If the system stayed active all night, the animals could study it, recognize the warning signs, and eventually learn to avoid it. By activating only when hunger overpowered caution, Marcus encouraged the hogs to approach before their nervous systems shifted into a more defensive state. Combined with invisible fencing and scent corridors, this strategy transformed the fight. Farmers were no longer reacting randomly. They were striking during the exact moments when the hogs were most vulnerable. But one challenge remained. Even after controlling the local herd, new hogs continued arriving from neighboring properties, forcing Marcus to look beyond ground-level defenses. The fight was far from over, but with timing and scent mastered, the foundation was in place for even more advanced tools to tip the scales definitively: aerial surveillance and reproduction control. Even with invisible fences, scent corridors, and perfectly timed traps, Marcus Webb faced one final challenge. New hogs kept moving in from neighboring lands, replacing the ones already removed. It became clear that ground-based defenses alone weren't enough. Farmers needed a way to detect entire herds before they reached the fields. In 2024, some farms out near Harvey County, Kansas, started using drones with infrared cameras and some artificial intelligence stuff, kind of like quietly looking around at night. These things flew so silently that you would almost miss them, and they could spot feral hogs without leaving behind any human scent, or even the obvious noise people normally make. On the first night alone, they found 3 different groups, and response crews were able to get there before the hogs went scattering light away. Then, over roughly 6 weeks, the whole setup reportedly helped take out 147 hogs. What made it work was not some magic button, but more like they used a gap that the animals never really had reason to learn. Feral hogs can be really good at dodging ground threats. Think people, vehicles, even gunfire. But they do not really have an automatic defense for danger coming from above. So the farmers basically got an edge. The hogs couldn't adjust too fast enough. Now the drones only handled part of it, though. Feral hogs breed crazy fast. One sow can put out 2 litters a year, and each litter can have 5 to 6 piglets. To curb that, researchers built an immunocontraceptive vaccine called Gonacon. It suppresses reproductive hormones and keeps fertility low for years after a single shot, after which they're still testing newer options that might last even longer, maybe by delivering the vaccine through bait. And the approach matters too. By focusing on lead sows while also keeping the herd structure pretty much in place, farmers can reduce numbers gradually, instead of causing rapid replacement. In 2024, Marcus Webb's sugarcane fields saw 0 crop damage for the first time in 4 years. Texas farmers turned the tide against feral hogs by combining science, technology, and keen observation. By targeting their weaknesses in vision, smell, timing, and reproduction, they stopped losing millions and reclaimed their land. If this story changed what you thought about pest control, hit like and subscribe for more surprising solutions from the world around us. And before you go, watch the next video shown on your screen to discover another unexpected way people are using science to solve problems once thought impossible. Thanks for watching.